How are you? I am considering all of you as a student because here I am going to teach to you something, and that something is a chapter of math of class 10th. That's why I will be considering you as a student, sometimes friend. Okay. Uh, Perhaps I will be taking a lot of lecture, not a lot of, but some lectures. Right now, you can see I am starting with application of a trigonometry. After completing this concept of this chapter, we will move towards the chapter. Okay. So I am trying to tell you that we will not see only one chapter. Apart from this chapter, we will move also on the other chapter. Okay. Yeah, I am going to do like that because the reason is that I want to cover all the concepts of all chapters of a class 10th. Okay, this is what is my motive. Okay, uh, numeric solutions, answer questions, uh, questions answers, exercise this that. So here questions answers I will tell you about how to solve this question, how to solve this particular question. It will be discussed in separate lecture. In separate lecture. With the help of this board, I will be explaining all the questions. I will tell you how to solve those kind of questions that are we going to study concepts of those questions. We will take some questions based on this chapters, but whatever we will take number of questions, we will solve those questions in separately. So in this lecture you will learn, you will take knowledge of concepts of class 10. In the other separate lecture you are going to do practice. That separate lecture will be practice session. Clear? In this our focus will be on the concept, on the discussion of the concept. So I want to start right now. I would say just stay with me for 1 hour, a dead hour. Okay, one hour 30 minutes. Then again we will start. Yeah, sometimes it can happen. What will happen? We will not be able to complete all the concepts only within a 1 hour. Okay, within a 1 hour. It will not be possible. If it will be possible, then okay, let's say after 1 hour or 1 hour 30 minutes, you will know that yes, it was possible or not. Hmm. If we are not able, if we are not able to complete to cover all the chapters, then don't worry. In other lecture, we will cover. So here I am telling that 10 chapters, number of chapters could be 13, 14. So these are numbers of chapters. Okay, if this number of chapters will not be possible to cover in 1 hour, then we will take another chapter, another lecture also. Okay. Now let's start. Introduction. Some applications of trigonometry. Applications. Here our focus will be on application. Some application of trigonometry. A student in class 10 will learn how to use trigonometry. You will see that there is a separate chapter of trigonometry, but in this here we will see application of trigonometry. Okay, application of trigonometry. one thing is coming is that you will have to understand the first part of this trigonometry, and this is the second part. Okay. If you are not complete with the first part of trigonometry, then it will be difficult for you. Okay, it can happen if your basics of trigonometry is not completed. So I would say, if you want to watch this lecture, see, okay, watch this lecture. If you are feeling that yes, I am not able to understand this part, this topic, then after watching this lecture, you can go to the first part. Otherwise, you will see. I hope I will be covering first part of a trigonometry. Don't worry in this lecture. So I said is that you should have knowledge of trigonometry of part 1. Clear? Okay. So we are going to use trigonometry to determine the height and the distance of different atoms. We will take atoms. So we will see height of that atom, distance between two atoms. Clear? Without having to measure them. We will not measure by using a scale, by using measuring tools. We will not measure like that. Here something we will be applying. Rather than using scale type measuring tools, we will use something else. So how to measure distance, height of atoms without having to measure them? Trigonometry was once used by astronomers to compute the distance between the planets and the earth and stars. Here, look at this sentence that I highlighted here over here. It is telling that there was a time a person whose name was astronomers. That person used this trigonometry to compute distance between planets, the stars, and earth. Between this distance between this, so that person thought, here, can I found the distance between this planets and earth? So I am assuming that yes, he will be able he would be able to find the distance between them. So how? It became possible because of he used trigonometry. He used trigonometry. We can use this trigonometry to find the distance or height of the atoms when we are not able to apply measuring tools. For example, a scale. Okay. In that case, you will use trigonometry. Yeah, it can happen. Just think. You will think, yeah, what would be distance from that point till this point? Sometimes your mind would say like that. In that case, what would you do? In that case. So here, your mind would say, yes, just use a trigonometry. Clear? Here you are understanding why are we going to discuss this. This is what you are understanding, and you have understood. Clear? In geography and navigation, trigonometry is mostly frequently used to identify latitude and longitude of a specified position. Clear? In these places, in geography you can see navigation. Students will be able to learn the concept such as height and distance, the line of sight, angle of elevation, horizontal line, angle of depression in this chapter. In this you can see there are some words which are coming, maybe stranger for you. Here a line of a sight. Yeah, you are familiar with the height, you are also familiar with the distance, but I am assuming that some of you would not be able to understand the meaning of line of a sight, angle of elevation, angle of a depression. I am assuming there are some people who will not be able to understand this. Don't worry, this is what is our topic in this lecture. Clear? In this chapter we will see this line of sight, angle of elevation, horizontal line, and angle of depression. Don't panic, I am telling you, don't panic. It is not too much difficult. I am here with you, I will instructor you, or you can say educator. I am your educator. So here my work is to teach, is to explain something in details with examples. Whatever will be possible to take examples to teach you, then I will take that example. But that example should be related to our lecture, okay? Not unnecessary. Uh, so remember, all these are our topics. Okay? Students can get to know the concepts very well by solving problems. Yes, yes, yes. This point try to understand. Uh, in a starting, I told you that only our focus will be in this lecture. Only our focus will be on the concept of the chapter. Now, what about solving the problems? Yeah. So I have also said you that we will take separate lecture for solving the problems based on this chapter. If you are understanding only concept, not solving the problem, if you are not solving the problem, then it will be incomplete. Okay, it will be incomplete. Using 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 trigonometric ratios, you are familiar with this. There are 6 which are fixed. 3 are just reciprocal of other 3. So all the numerical problem are solved in this chapter. Yeah, but one two question we will analyze, but except 2 questions we will ignore those. Okay, of every chapter, of every topic. Okay, to get complete solution for this is for you. Some applications of trigonometric, click. Okay, in this link we will get solutions, we will get exercise, question answers, solve problems. Now we have started to understand topics. So light over here you can see horizontal level and line of a sight. Horizontal level and line of a sight. Can you explain me what is a line of a sight? Horizontal level, which means horizontal which means like that, just a straight line. Horizontal is a line which will look like this, and vertical is like that, isn't it? So what is the meaning of a line of a sight? Sight, which means observer, person who is observing, the place where person is observing, that we observe from here, so it is our sight. Okay, so from here a line of a sight, which means we are observing something. So this is one point, and another point is where we are observing something, so that observing object will be second point. So from here to that object, this is a line, and this line will be considered as a line of a sight. Let's see what is the meaning of a line of a sight by this book language. So line of sight is the line drawn from the eye, you can see, from the eye of the observer to the point on the object viewed by the observer. It's all about observer. Eye of the observer, this is the first point, and whatever is being observed by the observer. So that object which is being observed by the observer will be second point, and between this distance, this line from the first point till the another point, this line is a line of a sight. Clear? This was the meaning of a line of a sight. I hope you are crystal clear. The next line is the horizontal level is the horizontal line. Yeah, I have told you, through the eye of the observer. Yeah, just over here understand, yes, horizontal is a line which will look like this, clear? And line of a sight is also a line, but there will be 2 points. First point where first point is the eye of the observer, and second point is the object which is being observed by the observer. This is what is the second point, and between this it will draw a line. Now next, here we have a figure to visualize it. This is a person. You can easily see this is a person. What is happening over here? From this figure, after visualizing it, you will be able to realize, yes, this is what is a line of a side. This is a horizontal level. Here, this is observer. This person is observer because it is observing something. It is observing that there is a lamp. It is a lamp. I am considering it as a lamp. So this person is observing over here, this top of this object. So from here to till here, this eye and this object here, this is surface of this object is being observed. This is second point. So this line is nothing but just a line of sight. Clear? Now what about the horizontal level? Look at over here. It will look like that. Here you can see this is. So from the eye, just from the eye, this will be known as horizontal level. I am not saying horizontal line. So from the eye, we will draw a line which will start from the eye of the observer. Okay, and it will go till the end. Okay, this is just an imaginary line. This is object, and this is the ground level. In this we have understood meaning of line of sight, meaning of a horizontal level. Let's move towards it. Next we have line of a sight and horizontal. We have discussed it. To know more about height and distance, visit. No, you are crystal clear about it. Next topic is that angle of elevation. Don't panic. We can understand it. Angle, you know that angle is formed by the help of a two-line segment. If you have more than two-line segment, then you will be able to form more angles. Okay. So if you have right now two-line segments, then you will be able to form only one angle. Okay, it doesn't matter what is the number of angles do you have. It doesn't matter. Matters is that elevation. What is elevation? what is elevation? Angle of elevation. The angle of elevation is a relevant for object. For object. Here I am talking about here. The angle of elevation is relevant for object above the horizontal level. It is telling me that just this horizontal level, okay, this horizontal. So the angle of elevation is relevant for the object above the horizontal level. This is so above of this is below, and this is above. So above of this will form what? This will be forming a angle, and this will be observe a line of a side. So line a angle which is between line of a side and horizontal level, and it should be above. Okay, it should be above. So this forming angle is the angle of elevation. So this is the angle, but it will form above the horizontal level. Here horizontal level is helping us to find out the angle of elevation, and that's why it was compulsory to understand the meaning of horizontal level. So below the a angle which is being formed below the horizontal level will be known as something else, depression of angle of depression. Okay, we will see, don't worry. Right now we saw that yes, angle of elevation is an angle, and it will form itself above the horizontal level by the help of a line of the side. So this is the angle of elevation. Here you can see it is the angle formed by the line of a side with the horizontal level, but it should be upper, above. Okay, in the below mentioned diagram, theta denotes the angle of elevation. Let's see, this is object and this is observer, line of a side. Here you can see this is below, this is will be, if a angle is being formed below, this will be considered something, but right now it is above the horizontal line. That's why this will be known as what angle of elevation. Okay, angle of elevation is an angle, but it forms above the horizontal line. That's it. Angle of elevation. To know more about the angle of elevation, visit here. No, we don't need to go into too much details about this angle of elevation. This was enough to understand about. Now what about angle of depression? What about all these are topics, or you can say this is the concept of this chapter. Okay, you are making your foundation strong. Are you understanding? If you don't know about this, here you are making your understanding regarding this strong. Okay, let's see a discussion of angle of depression. This is also an angle. Just whatever we saw about angle of elevation, just opposite of angle of elevation is the definition of angle of depression. So angle of depression is what? It is just an angle, and it will be forming below the horizontal with the help of a line of a side. So now line of sight will not be above the horizontal, it will be below the horizontal. Okay, you will see. Here you can see the angle of depression is relevant for objects below the horizontal line. It is the angle formed by the line of a sight. This line of a sight will be also below the horizontal level, with the horizontal level. With the example, let's try to understand. This is a object. We are considering this horizontal level. Okay, this line has a horizontal level. So this above of this horizontal will be angle of elevation. But right now you can see this is below the horizontal level. So that's why this will be angle of depression. And who is observing this? This mouse is observing this part. This mouse is observing this part. So this line, I think this is observing this. Okay, this is observing this according to this. So this is a line of a sight. Line of a sight is a line which is known as observation. RQ is a height. Yeah, this is a height. We are understanding some parts of this trigonometry. Some parts we have seen horizontal level, angle of depression, angle of elevation, line of a sight, height also, distance also. Calculating height and distance. To calculate height and distance, we can make use of a trigonometric ratio. Go through the below trigonometric ratio table for reference. You are familiar with this. This 0 degree is equal to this. This 30 degree is equal to this radian. Remember also. Okay. 45 degree will be equal to pi upon 4 radian. So sine 0 degree is 0, sine pi upon 6 is a 1 by 2. All these are values of a trigonometric ratio. It will be used. This will be used. Okay, don't worry. This will be used in question. In question, this will be used. Let's see what is the process of a solving question. First step is that draw a diagram. Draw a line diagram corresponding to the problem. Mark all the noun heights. Whatever you know by the help of question. Just draw height, okay. Distance, angles. If you don't know distance, just avoid right now distance. And whatever you know, if you know that measure of this line is something, just write that measure of that line. This is just a step to solve the problem. Denote unknown lengths by variables. Yes, whatever you don't know, just you can represent that unknown length by just a variable. And here you can understand why to use variable. Variable you will use to represent unknown lengths. If you want to find length of unknown length, then you will have to use variable. Okay, this will be logic. Next we have use the values of various trigonometric ratio of the angle to obtain the unknown length from the known lengths. Height and distance. Angle of elevation, this alpha, this angle of elevation alpha, and this beta will be angle of. Sometimes you will see in question what will you be observing? You will be observing that theta is coming, beta is coming. So don't forget that theta is just angle of elevation and beta is just angle of depression. This is the line of a sight and this is a distance. This base will be distance and this height will be, this AB will be height. You are familiar with it. From the given diagram, if C is the point of the observation, this C is the observation point. So AC is the line of a sight. AC where this AC line of a sight. BC is the distance between the observer and the object. BC. Distance. Observer. This is observer and the object. This is object. AB is the height of the object. This AB. it is AB is a totally object. AB is a completely object. This alpha is the angle of elevation, and sometimes you will see uh, beta is being considered as a angle of depression. It will happen sometimes, so don't get confused at that time. To get to solve problems on heights and distance, we can visit over here, but right now not. So our concepts is crystal clear. We are able to solve numbers. Be more precise, measuring the distance of a Celsius body with the help of a trigonometry. We will see it. We will see it later. These are question answer. Let's pick the next question. I think next should be this circle. Introduction to circles. First of all, let's try to understand parts of a circle. Each parts of a circle. Whatever will be possible to understand as a concept. So a brief introduction to circles for class 10 is provided here. Get the complete description provided here. To learn more about the concept of a circle, also learn how to draw a tangent to the circle with the various theorems and examples. Okay. Let's start introduction to circle. Introduction to circles. As we know that a circle is a closed two-dimensional geometric figure. This circle is a two-dimensional. It is not a three-dimensional. So this circle will be closed, not open. It is always closed, not open. You will not see intersection. You will not see open area of a circle. That's why it is known as a closed two-dimensional. Next we have such that all points on the surface all the points on the surface of a circle are equidistant from the point called the center. The distance from the center to any point on the surface of a circle is called radius. It is talking about this. If you take this line, let's say from here to till here, measure of this radius is just 2 centimeter. So this line is telling you that if you take from here to till here, this will be also 2 centimeter. If you take from here to till here, this will be also 2 centimeter. This will be also 2 centimeter. This is what it is talking about. Okay. All this radius, measure of all this radius will be nothing but just 2 centimeter. If a measure of one radius is of 5, then measure of all the radius of that circle will be same height. Is it complete? Circles and line in a plane. For a circle and a line on a plane, there can be 3 possibilities. They can be non-intersecting. They can have a single common point. In this case, the line touches the circle. They can have 2 common points. In this case, the line cuts the circle. These are main points for this chapter. What is the meaning of this? They can be non-intersecting point. It is saying if we will take 2, this is 2. Okay. Here we took these 2 circles. Now tell me, are you able to see intersection view of these 2 circles? No. So this is what is known as non-intersecting. If you take 2 or 3 and both are not touched with to each other, in that case both it will be non-intersecting. But what about this? They can have a single common point. They can have two common points. Look at over here. There are three possibilities. One point inside this, second point outside of this circle, and third point will be on the circumference of the circle. These are 3 points. A point which is inside the circle will be what? I don't. Now look at over. Here there are 2 points, this and this. What is happening? What is happening over here? This line is not intersecting this. It is not also touching this. It can happen sometime. Here, if you touch this, if it touch this circle, then what will happen? It will do a tangent. This is known as a tangent line because it is just a touching. It is just a touching. It is not intersecting. And this also you can see it is not intersecting. In this also it is not intersecting. This is not intersecting with the help of this circle. This is just a touching. So a line which is a touching the circumference of the circle will be nothing but just a tangent line. And what about this? A line which is intersecting the circle. So this will be intersecting you. This will be known as something else. It is not a chord. AB is a chord, but PQ will be something else. I think it should be secant. So PQ is a tangent. This is a separate line. What is happening over here? This is non-intersecting. It is a touching, and this is a intersecting. This is what is happening. So let's see about a tangent. A tangent to a circle is a line that touches the circle at exactly one point. Not exact, but approximately at one. For every point on the circle, there is a unique tangent passing through it. Okay. If you draw over here, then you will also get tangent. If you draw over here, at every point, you will get a tangent. To know more about a tangent, visit over here. What about secant? Here we were saying AB is a chord, but AB will not be considered as a secant. This PQ will be secant. This secant is a line which starts from the outside of the circle and it intersects this circle like that. This line PQ will be secant. Clear? Okay. Tangent as a special case of a secant. Tangent in blue. This is a tangent. This blue is a tangent, but this will not be known as a tangent. It is a intersecting. So remember, tangent will not intersect at all. Tangent will also only it will touch the circumference of the circle. That's it. But here you can see all these lines which are in black color. All these are intersecting this circle. So just intersecting line will be secant. A tangent to a circle can be seen as a special case of the secant when the two endpoints of its corresponding chord coincide. Yeah, this secant can give you chord, but secant will not be equal to chord. Two parallel tangents at most for a given second. For every given secant of a circle, there are exactly two tangents. There are exactly two tangents which are parallel. There are exactly two tangents There are exactly two tangents which are parallel to it and touches the circle at a two diametrically opposite. Here you can see. It is telling you that if you draw two tangents, then this two tangent will be parallel. But this parallel, this line, it is not a tangent. This is a what? So here only two line can be tangent which will be parallel to each other. And this, it is a truth that there will be only two line which will be tangent. Okay, which will be tangent will be parallel to each other. Except this tangent line, you can see all these are parallels. This second line. And here PQ is nothing but just it is a diameter also, and it is also forming a secant. PQ is the secant of the circle. Theorem, let's see. Tangent perpendicular to the radius at the point of a contact. Theorem number 1. The theorem states that the tangent to the circle at any point is the perpendicular to the radius of the circle that passes through the point of contact. No, I didn't understand. This OP is a perpendicular. In that case, let's see what is happening. This perpendicular, you know that it forms a 90 degree. You are crystal clear about this. This is a forming 90 degree, and this side is also it is a forming 90 degree. So this sum of this 90 will become how much? 180 degree. 180 degree. So remember, this only perpendicular will give you 90 degree angle. Okay, this perpendicular. This OQ is not perpendicular because it is not exact vertical, and this is not equal to radius. OQ is not equal to radius, but here OP is a radius, and it is also forming perpendicular, and it is also giving it is a perpendicular to yx. This is a perpendicular to yx, so it is also giving you angle. It is also, this OP is also a radius, but this OQ is not a radius. Clear? Okay. In this you saw first theorem. First theorem is that this perpendicular will be radius, and it will give you 90 degree angle. Here O is the center and OP is the perpendicular to xy. Theorem 2. The number of tangents drawn from a given point. Next theorem. Here there is a one point inside the circle. Now what will be number of line which will be drawn by the help of a point? This. It is giving you infinity. If the point is in an interior region of the circle, any line through that point will be a secant. So no tangent can be drawn to a circle. Yeah, it will not give you. Of course, we are clear that this will not give you tangent because it is inside. If you try to draw a tangent line, then either it will give you a chord or a diameter if a point is over here at the center, then it can also give you, this can also, it is right now it is giving you secant line. All these are possible except a tangent. Okay, except a tangent. This point which is inside the circle will not give you tangent line. Remember, a point which is at the circumference of the circle, in that case you will get a tangent, but not a secant. You will not get secant. You will also not get a chord. if point is over here, point is at a circumference. In this case, you are getting tangent, not secant, not also chord. Clear? Like that you will get. What about a point which is outside the circle? In that case, what will happen? Let's just say there is a point which is outside of this circle. What will happen right now? Yeah, either we can draw two this is two this is two. I know that this is not exact. This is two a tangent line. Not if you try to third, then it will give you second. It will give you second. Okay, so it will only give you two tangent line, one or two times. There are only, if you do like that, it is not a tangent. This is not a tangent. It is giving you ending. This both sides will be infinity. Here you can see it is touching, but if you draw ahead of this, it will go inside this, and this will, it is not a tangent, as you know. We saw three things. First, if a point is inside the circle, in that case you will not get tangent line. You will be getting what? Secant, chord, diameter, but not a tangent. This is a truth. It is a universal truth. Now, if there is a point which is at the circumference of the circle, in that case you will get only one tangent. You will not be getting secant line, okay, chord, diameter. In the other case, there is a one point which is outside the circle. In that case, you will be getting two tangent line, two tangent, one or two. Number of a tangent line will be two. Clear? I hope you are crystal clear. AB is a secant drawn through the point S. We have seen it is providing a tangent line. Here this P is a point, and with the help of this it is providing two tangent lines. Length of a tangent. The length of a tangent from the point say P to the circle is defined as this segment. With this circle, in this case PL is the tangent line. It is infinity. This arrow is showing infinity, but from P it is the ending side, this is the starting side. From P to till the L, this will be complete tangent length of a tangent. Lengths of a tangent drawn from an external point. Lengths of the tangent drawn from an external point to a circle are equal. What is it saying? From here, PQ, this is one length of a tangent. So this theorem is telling that whatever will be measure of this PQ will be equal to this PR. If this PQ is providing 5 centimeter measurement of this, then this PR will be also 5 centimeter. This is what is happening. But don't think that PR will be equal to PO. No, PO is bigger than this PR and PQ. OQ is a radius, OR is also radius. OR is also radius. In this theorem, you saw that this PQ tangent will be, if there are two tangents which is being formed, which is being drawn by the help of external point of the circle. In that case, this two tangent measure of these two tangents will be equally to each other. Assume that we are provided with a circle whose center is O and P is the point that lies outside the circle. Okay. This is for you. Theorem number 10.1. The tangent at a point of the circle is a perpendicular to radius through the point of a contact. It is a complete. It is a completed. This is complete. We have completed concepts of this chapter. Let's take next chapter. Next we have areas related circle. Next coordinate. Let's see coordinate polynomial. What do you think about it? Quadratic, which means variable is getting two exponent. Highest exponent of the polynomial is coming how much? 2. This is what is the meaning of a quadratic. Quadratic, which means exponent, highest exponent should be 2 in the polynomial. Did you understand about the quadratic polynomial? Look, quadratic polynomial, it is already polynomial. Now here quadratic, which means a polynomial is getting highest exponent how much? 2. If highest exponent is a 3, then this polynomial will not be considered as a quadratic equation because of highest exponent is a 3. That's why a polynomial of the form, this is a general form. Polynomial will look like that. In this case, ABC will be integer, C is a constant, AB will be known as a coefficient, and here highest exponent is 2 of the variable. Highest exponent, here this x is also containing one exponent, but we are not talking about this because of here we are saying highest exponent. So highest exponent is how much? 2. Okay, C is not with a variable. That's why this will be known as a number which is not with variable will be constant. A number which is with variable will be coefficient number. That's it. So where A, B, C are real number and A should not be equal to 0. B could be equal to 0. C could be equal to 0. But A will not be always equal to 0. If you put 0 in the place of A, in that case this this whole polynomial will not give you quadratic. It will become 0. This term ax square will become 0, and you can see it is not giving us highest exponent 2. Is called a quadratic polynomial. This was a definition. Quadratic equation, just we add equal sign. When we will be adding equal sign, then here we are saying that in the left side, in the right side, there are some quantities. This first quantities which is inside the, which is in left side will be equal to other side. These two quantities which are in its same sides. Quadratic equation, when we equate a quadratic polynomial to a constant, we get a quadratic equation. Any equation of the form this px is equal to k, where px is a polynomial of a degree 2 and c is a constant, k is a constant, is a quadratic equation. Just we add over here this equal sign. Okay, this equal sign. So the standard form of a quadratic equation, this is a standard form, it is also general form. We will see use of this standard form. Where ABC, yeah, we have seen this. This a is the coefficient of x square. Yeah, remember, if a question asked to you what is the coefficient of x square, then you will say a is the coefficient of x square, b is the coefficient of x. You will see some question based on this. It is called the quadratic coefficient. B is also coefficient, but C will not be coefficient. It is called this B. It is called the linear coefficient. Here, this is here you are getting how much? A is with quadratic. That's why this is a quadratic coefficient, and here B is with linear. So that's why this will be known as linear coefficient. Is the constant. C is a constant. We will say it later. Solving quadratic equation by factorization. Roots of a quadratic equation. What is root? Root is just a answer of x, value of x. Whatever you are getting value of x in the answer, that root will be, that answer will be root. So number of roots in this chapter, you will see 2 roots. So answer of one input will be 2 output. Input of one variable will be 2 output. This is what you will realize meaning of roots. So roots of a quadratic equation, the value of x for which a quadratic equation is satisfied are called roots. If you put value of x in the quadratic equation, then that LHS will become, should become equal to RHS. In that case, you can say whatever you applied value of x is a valid value. Now next we have, if a is the root of the quadratic equation of this, then this will become this a square plus ba plus c is equal to 0. It is not a real life example, don't worry. We will see some examples to understand about roots. A quadratic equation can have two distinct real roots. Two equal roots or real roots may not exist. Graphically, the roots of a quadratic equation are the points where the graph of the quadratic polynomial cuts the x-axis. Considering the graph of a quadratic equation, x square minus 4 is equal to 0. So minus 4 is nothing but, minus 4 is giving you four. So this minus 4. So minus 4, y is a minus 4 and x square, which means this x value of the x is coming how much? 2. So this 2, it will be intersecting over here. Okay, like that. So quadratic equation will look like that on the graph. Value of x is over here is -2 and y is how much? -4. Graph of a quadratic equation in the -2 and 2 are the roots of the quadratic equation. Yeah, here you can see this value of 1x is coming how much? 2, and value of another x is also coming 2, but it is giving you -2 and it is giving you 1 2. When you will simplify this, then you will get x is equal to -2 minus plus 2. Graph of a quadratic equation. Okay, we are crystal clear about it. If the graph of the quadratic polynomial cuts the x-axis at two distinct points, then it has a real distinct roots. Yeah, you can see it is a cutting. So this is giving you real. -2 is a real, 2 is also real. Because it is giving you intersection with that side. If the graph of the quadratic polynomial touches the x-axis, only if it touch this x-axis like that, only touches it, not intersecting like that. Only a graph is touching like that. In that case, then it has a equal. No, yes, it has a real and equal. You will get a real number, but that real number will be equal. If a real number is a -2, then another value of x will be also -2. It will happen when a graph is touching the x-axis there. Okay, not intersecting it. So if the graph in the third, if the graph of the quadratic polynomial does not cut or touch, if a graph which is not touching, it is neither touching nor cutting. In that case, it does not have any real roots. Okay, any real root. So it will give you complex number. Complex. A graph which is not touching the x-axis and it is also not giving you intersection. In that case, this will not give you real roots. Okay, real root. A graph which is only touching the x-axis, in that case, this will give you it will be giving you equal real roots. A graph which is giving you intersection way, in that case number is real, but it is unequal. This will be distinct point. Solving a quadratic equation by factorization method. Here you will use the splitting method. This is for you. Just a splitting method. Split this middle term. Minus 9. 3 2 is 6. 2 3 is so -3 -2. Just two numbers will be written where here you are saying it is not working here. Here you are saying this -2x -3x is equal to -5x. This is what you are saying. We didn't change our equation. Okay, remember, this is equal to this. This step is splitting the middle term. Yeah, we split the middle term by finding two numbers, and those two numbers are -2 and -3, such that their sum is equal to the coefficient of x and their product is equal to the product of a coefficient of x square and the constant number. Here you can see the sum of these two numbers is equal to coefficient of a b, and this product of these two numbers is equal to product of a coefficient of x square and a constant number. In this step, we have expressed the quadratic equation polynomial as a product of its factor we are getting x as a 1 and x as a 3 upon 2. Value of one input is coming to output. Here real roots is numbers are real. This one is real, 3 upon 2 is real, and both are unequal. So graph will look like that. It will be intersecting. It will be intersecting the x-axis. Okay. This method of solving a quadratic equation is called the factorization method. Here you were splitting the middle term. This method is known as just you are if you are splitting the middle term of the quadratic polynomial, it means you are using factorization method. Solving a quadratic equation by completion of a square methods. I am also unfamiliar with this. Solving a quadratic equation by completion of a square methods. In the method of completing the square, the quadratic equation is expressed in the form of just we will apply a square in both sides, not only in one side. If you do like that, then our equation will remain as it. We will not be able to change our equation. If we apply whatever you are going to apply in one side, just apply also in another side. Okay. Here you can see in this case we are applying this square in this side, but in the right side also we will apply. Okay, we will not ignore in this case, in other side. Consider the quadratic equation. This is a quadratic equation. So here it will give you this general form. So express the quadratic equation in this standard form. This is in standard form. Now divide the equation by the coefficient of x square. Okay, x square to make the coefficient of x square equal to 1. So here just we divided by 2 by 2. Add the square of a half of the coefficient just here, x square plus 2k plus k square minus 5x x square minus 4x. So 4x is the perfect square of 2 to the 4, x square minus 2 to the 4x and 2 to the 4. Here algebraic identity was applied over here. Plus 4. I think in both sides plus 4 was applied. Plus 4, not algebraic identities. In that case, what is happening over here? This is equal to x minus raised to power 2. Here algebraic method is coming, and this minus 5 will go in this side. It will become 9. Take the positive and negative square roots. This x square, it will give you x as a 5 and then x as a minus 1. What is the discriminant? Discriminant will tell you nature of the roots. Nature of the root. Yeah, nature of the roots. So to find the discriminant, we will have to use this formula: b square minus 4ac. B is the coefficient of middle term of x, and 4 is a number. A is a coefficient of a quadratic coefficient. C is a constant. After simplifying our expression by this formula, we will get value of t. If t is equal to 0, will be something. If t is greater than, if t is less than 0, then in this discussion you will get nature of roots. The discriminant determines the nature of the roots of the quadratic equation based on the coefficient of the quadratic equation. Nature of roots here. Discriminant is equal to nature of roots. Here, look at it. In first case, if t is greater than 0, for example, it is not giving you minus 1. This is not giving you minus 10, minus 1 upon t is a greater than 0. It can be 1, it can be 100. So I think it is natural number, yeah. Equation has a two distinct real roots. Yeah, if t is greater than 0, then a real number would be real, but both will be unequal, not equal. In the second case, if t is equal to 0, then real but equal, real but equal. For example, value of 1x is coming 2, so value of another x will be also 2, so 2 is also real, has a two equal roots. If t is less than 0, in that case, yeah, here a number will be in under root, and in under root a number will be with a negative sign, and you know that a number which is under root, which is in under root with a negative sign, is nothing but just a complex number. Okay, complex number is not a real number. Real number is not a complex number. These three cases will come to you when you will be solving quadratic formula. If you find a discriminant, then you will be able to visualize, yes, our real number is going to be this, nature of our real number is coming this. Okay, this that. This is graph quadratic equation. What is happening over here? It is telling that that d is greater than 0, because it is providing intersection view. It's not touching the x-axis, you can say. So value of first x is how much? Value of first x is -3, and value of second x is -2, and y is 6. Y is how much? 6. So here this three graphs you will be getting by solving quadratic equation. Either you will get this graph, either the second graph will look like that, third graph will look like that. It is telling that it's an intersection with, this is a touching, it is a touching. In this case, d is greater than 0, and this is equal to 0, and this d is 0 is greater than d. This is what is happening. We are able to visualize it. Okay, formation of a quadratic equation from its product of the roots. Sum of roots, just alpha plus beta. Alpha is a root, beta is also root. Okay, we are considering alpha as a first root and beta as a second root. Okay? And c, you will get c by the help of this product of two roots. You will get p by the help of this root, this product roots, sum of roots. Sum and product of roots of a quadratic equation. Remember, sum of the roots will be equal to minus b upon e, where minus b is the coefficient of x and a is the coefficient of x square. Product of roots will be equal to c upon e. This is clear. This part is clear. Three chapters we have completed in this with understanding. Whatever we left We will discuss those chapters which are left in the next separate lecture.